Hey guys, in this video we're going to talk about interval notation and compound inequalities. So in the last video we looked at solving inequalities and we plotted our solutions on a number line. So what we did, we drew a line through the inequality sign and we isolated x just like we did when we were solving equations. So we could subtract 4 from both sides, giving us 2x is bigger than or equal to 1. And then we divided both sides by 2 to get x is bigger than or equal to 1/2. And that was our solution. And we plotted it on a number line like so. So we graphed 1/2. We put a closed dot there because of the line under the greater than sign. And then we shaded everything to the right of 1/2, which indicated that everything greater than 1/2 is going to be in this set. So I'm going to teach you guys another way to write this same thing in a different way, a more sophisticated way, if you will. And you know, if you guys, especially if you guys are taking college algebra, you're going to need to know this. And it's called interval notation, okay? And this right here is called inequality notation. Sometimes it's called that. There's other names for it, but I like to call it inequality notation. Now, interval notation means that instead of using less than or equal to signs, we're going to be using brackets and parentheses. We're going to do a bunch of examples like this, but I want to represent all of this in the following way. I want to start at 1/2, and then I want to go all the way forever and ever to the right. Now, what does that mean, go all the way forever and ever to the right? Well, that means we're going off to positive infinity, right? Anything bigger than 1/2 is gonna go off to positive infinity. Now, on the left side, we have negative infinity, so we can make a negative number as small as we like. Okay, so this is the number line. We have, you know, negative infinity all the way to the left, which is technically not a number, but it's an idea, right? And then to the right, we have positive infinity. So the way that we represent 1/2, everything to the right of 1/2, we go from 1/2 to positive infinity, and we put a bracket at 1/2 to include 1/2 in our set. And the reason we include it is because we have a closed dot. We never include infinity because infinity is technically not a number. It's an idea, it's a concept. So to indicate that we're not including something, we put it with a bracket. So this means the same exact thing as x is bigger than or equal to 1/2. Literally means the same thing. It says, hey, start at 1/2, go all the way to infinity, and that's our set. Okay, so let's do some practice with this. Now, here's some quick notes on notation. So when we have an open dot, we use parentheses. That means not included. So this means not included. We're not including whatever we're putting parentheses in our set. Now, the closed dot gets a bracket. That means we're including it. Just like here, we included 1/2 in our set. And this U means union, okay? And basically union means everything, you know, everything together, joined with. We're basically joining two sets. If I union two sets, we're joining the two together. Okay. So let's do some practice writing these sets in interval notation using the brackets and parentheses. So we always start at the number that we see first. So we're starting at -3, and we're shading to the right. So I'm going to put a comma going to the right, and we're going all the way to positive infinity. Now, again, infinity always gets a parentheses, and that -3 is included because of the closed dot, so this is my answer. And to read that, you would say -3, you would say this is the set -3 to positive infinity. Okay, this is the set including -3 All numbers from -3 up to positive infinity, okay? Let's do the next one. So we see a 2, so I'm going to write a 2 there. Now this time it goes all the way to the left. So the lowest number comes first in your set. So the smallest thing here, we're starting at negative infinity, right? We go from left to right when we order numbers. So we start at negative infinity. We go all the way up to positive 2 and stop. So our set looks like this, and the way that you would say it was you would say the set from negative infinity to positive 2. That's all of this. Remember to write your smallest number first, okay? Negative infinity, of course, is smaller than 2. What about this one? This one we're going from -1 is the smallest thing shaded, all the way to 10. Now, -1 gets a bracket because he has a closed dot, and 10 gets a parentheses because he has an open dot, and that's our answer. So that is the set of numbers from -1 up to positive 10. That's what's shaded there. Alright, what about this set? Now it's broken up, so we're going to have to join sets with the union symbol. Now this set, the lowest number in this set is negative infinity. So we start there. The biggest number in the set is -8, so we end there. So that's the set from from negative infinity all the way to -8. Now we're going to join the other set. The other set, we start at the lowest number 30, and by the way, 30 is going to get a bracket because he's included. And then we're going to go all the way up to positive infinity. And infinities always get parentheses. So this is our answer in interval notation. We have the set from negative infinity to -8 unioned with the set from 30 to infinity. Okay. What about this one? So this one we have to do two unions, two joins. So the first set right here, smallest number in the set is -5. Biggest number where it ends is 0. So -5 gets a parenthesis since it's an open dot, and 0 gets a bracket since it's a closed dot. Then we're going to join that with this next set, this next intermediate set from 3 to 4. So we start at the smallest number 3, and 3 gets a bracket because it's got a closed dot. And we go all the way up to 4, and we give it a bracket. Now, we're not going to go all the way up to 5 because we don't want to include like 4.5 or something like that in our set. It's kind of disjoint, as you can see. So we're going from 3 to 4, and we're going to union that with this final set, which starts at a number 5 and goes all the way off to positive infinity. And we're not going to include 5, so we're going to give that a parentheses. So this is our answer. Okay. Alright, what about this one? So looking at this first set, we're going from -1 is the smallest up to 2 is the biggest. Now 2 gets a bracket, or sorry, a parentheses because it has an open dot. And -1 gets a bracket because it has a closed dot. Then we're going to union it with the next set that we see over here. So the next set, we start at 8, we go off to positive infinity. 8 gets a bracket because of the closed dot, and infinity always gets a parentheses. So this is our answer in interval notation. Okay, represent this inequality. X is bigger than or equal to 2, less than 4 in interval notation. So if it helps you, you can write it out. You can start with x because it's in the middle. You can say x is greater than or equal to 2. X is less than 4. Okay, so we have our, I'll put my two numbers there. So 2 could be right here, 4 could be right here, and and the set is sandwiched between 2 and 4. So it's going to be everything here because it's sandwiched in the middle. And it's bigger than or equal to 2. So since it has that line under there, I'm going to give it a closed dot. And since it has a less than next to the 4, I'm going to give that an open dot. So that's my picture. So in interval notation, I start at 2 and I go to 4 and I give it a parenthesis. So this is the set, everything between 2 and 4, not including 2. That is x is bigger than or equal to 2 and less than 4. Okay. What about this one? X is greater than or equal to -3. So here's -3. It's getting a closed dot because of the line under the greater than. And everything to the right of it is going to get shaded off to positive infinity. Okay, positive infinity goes to the right, negative infinity goes to the left. Now, we start at -3, so -3 gets a bracket because we're including it. We're going all the way to infinity with my set. And I'm going to put a parenthesis there to indicate that we're dealing with infinity. So that's my answer in interval notation. Okay, so we want to solve graph, put your answer in interval notation. So let's go ahead and draw our line through the inequality. We're solving for p. So again, we're just trying to find a set, and we're going to write that set in interval notation. So I want to isolate p, and the first thing I'm going to do is I'm going to subtract 3 from both sides to do that. On the left, I get 2 times p. On the right, 5 minus 3 is going to give me 2. Now I can divide both sides by 2 to get p is greater than or equal to 1. Okay, so this is my solution, but I want to write it in interval notation. Okay? And, you can write a number line first. That means, that's what it means to graph these things. So we can put it on a number line, and I'll say 1 is right here. It's going to get a closed dot, and it's going to be everything to the right of 1. And we're going off to infinity. So in interval notation, what this looks like, we start at 1, and 1 gets a bracket because he's included, and we go off to positive infinity, and infinity never gets included. So this is my solution. These two things mean the same. P is greater than or equal to 1 is the same set as 1 to infinity. Those things mean the same thing, all right? So this is the graph, and this is the solution in interval notation. All right, let's do the next one. So let's go ahead and draw my line through the inequality sign. I want to isolate Q. So on the left, the first thing I'm going to do is I'm going to add 6 to both sides to give me -10 times Q is less than 30. Okay, now I'm going to divide by a -10 to get Q alone. And remember, guys, when I divide by a negative, when I'm dealing with inequalities, I need to make sure that I flip that inequality to face in the other direction. So I get Q is greater than -3. That's my solution, but I want to put it in interval notation. So the first thing I'll do is I'll graph this. So we have negative infinity all the way to the left, positive infinity to the right, and I'll put -3 right here. Doesn't really matter where I put it. Now, since there's no line under here, I'm going to put an open dot at -3, and I want to shade everything to the right of it because its Q is greater than -3. So everything to the right gets shaded, and in interval notation, I can write this. So I'm starting at my lowest number is -3, going all the way to infinity. Infinity always gets a parentheses, and -3 is also going to get a parentheses because it's an open dot. So this is my graph, and this is my solution in interval notation. Okay, let's do another one. Draw my line through the inequality. I'm isolating y. So first thing I'm going to do is I'm going to add 4 to both sides. That's going to give me 20 times y is less than or equal to negative 2. From here, I am going to divide both sides by 20 to get y alone. Noticing that I never divided or multiplied by a negative, so I do not need to flip a sign. So simplifying this by 2, divide top and bottom by 2, I get y is less than or equal to negative 1 over 10. Now, if I graph this, negative infinity, positive infinity, here's negative 1 over 10, just chilling somewhere, and he's going to get a closed dot because of that line under there. And I want to shade everybody to the left of him to indicate the set y is less than or equal to negative 1 over 10. So this is my graph. Now, in interval notation, my smallest number, quote-unquote number, is negative infinity. So I start at negative infinity, and I go all the way up until I hit negative 1 over 10, and I stop. And negative 1 over 10 gets a bracket because it's included, and negative infinity always gets a parentheses. So this is an interval, it's our solution in interval notation, and this is my graph. Okay, let's talk about something called compound inequalities. So a compound inequality is a statement that consists of at least 2 distinct inequalities that are joined together by the word and or the word or. So for example, this would be considered a compound inequality. It says x is less than negative 2 or x is greater than or equal to 1. With these types of inequalities, we only care if one of them is true because of the or. Now, the next one is an and inequality. It says x is greater than or equal to 3, and at the same time, x must be less than or equal to 4. So, we want both of these things to be true simultaneously with ands. And we're going to look at some examples with those. Let's first look at and. So, in a compound inequality, the word and refers to the point where the inequalities intersect. In other words, if we graph the two inequalities, we're looking for where they overlap. So we want the solution set to be true for both of them. Okay? So for example, let's graph the solution for x is greater than or equal to negative 1 and x is less than or equal to 4. So the way that I do these and problems is I first plot both of my numbers on the number line. And, when you're getting used to it, you can put your negative infinity and positive infinity there to keep you organized. Here's negative 1 and here's 4, right? My compound inequality, we have 2 numbers to deal with. So the first one I'm going to do in yellow. So the first one is x is greater than or equal to negative 1. So I'm going to shade this in yellow. Negative 1 gets a closed dot. And I'm going to shade everything to the right of that guy. Okay, so this is my first inequality right here. Okay, my second inequality says that x is less than or equal to 4. So I'm going to just I'm going to do this one in red. So this says x is less than or equal to 4, so I'm going to put my red dot there. And I'm going to shade everything to the left of 4. That's what that means. Okay? And so our solution is where they intersect, where they're both shaded. And it turns out they're both shaded starting at negative 1. We have a yellow and red shade there. All the way to positive 4. We have a yellow and red shade there. So that's our solution. So in interval notation, this is going to be from negative 1 to that should be a 1. So this is going to be from negative 1 to positive 4. And we're including both of those, so that is our solution in brackets where those things overlap. Okay, let's do another example. So we have x is greater than 0, and at the same time, x has to be bigger than or equal to negative 3. So I'm going to start by drawing my number line. Here's negative infinity, here's positive infinity, here is negative 3, and here's 0. So for the first one, I'll do it in yellow. X is bigger than 0, but I'm going to draw an open dot at 0 to make sure that I don't shade over it to say 0's in that set. So no yellow over there, but everything bigger than 0 gets some yellow. Okay, so that's my first set. And then the second set is x is bigger than or equal to negative 3. So this guy gets a closed dot at negative 3, and he gets some shading over it to include it. And everything bigger than negative 3 is getting included as well, including the dot right here. So I'll shade him there. Okay. But for our solution, since we have and, we're only going to include the parts where they overlap. Now, they don't overlap at 0 because there's no yellow shading on 0. So to say that we're not including 0, we're going to put the parentheses, we're going to start at 0, but everything to the right of 0 is valid. Like 0.00005 is definitely valid because it's shaded in yellow and red, but 0 is not. So we want to start at 0, but we don't want to include 0, and we want to go all the way to positive infinity, and that is our solution set right there in interval notation. All right, let's do this one. So we have x is bigger than 2, and at the same time, x is less than negative 4. So let's see what happens here. This is kind of interesting. So here's negative infinity, positive infinity, negative 4, positive 2. At negative 4, I'm giving him a open dot, and at 2, I'm giving him an open dot as well because both of those don't have lines under there. Now for the first set, x is bigger than 2. I'm not shading 2, but I'm shading everything to the right of 2 in yellow. And then for x is less than negative 4, I'm shading everything to the left of negative 4. Now what's our answer here? Where do these two guys intersect? Well, they don't intersect because there's no part on the graph that has both yellow and red. So the answer here is no solution. Okay, so we talked about and, now let's talk about the word or. So the word or means that you're looking at the union of the inequalities. So if we graph the two inequalities, we're looking at what happens when they're put together, and the final solution must be true for at least one of the inequalities. So for and, both inequalities had to hold, but for or, only one has to hold. Okay, so let's look at an example. So we want to graph x is less than negative 2 or x is less than or equal to negative 1. So we're not looking at the overlap here. We're just looking at these two sets being joined together, basically. Okay, so we have negative infinity, positive infinity, and then we have negative 2, and then negative 1 right here. Okay, so looking at the first one, we have x is less than negative 2, so that's going to be everything shaded to the left of negative 2, including negative 2. And then we have or x is less than or equal to negative 1. So because it's less than or equal to, I'm gonna go ahead and do a closed dot there, and then everything is gonna be shaded. Right. So we want to include all of this in our set, right? So we don't need to include just this part. That would be and. Or means everything can be everything that's shaded is included, no matter if it's shaded red or yellow. Okay. So to say that, we can say that all of this is shaded, right? So in interval notation, we're starting at negative infinity, not including it, of course, and we're going all the way up to negative 1, including negative 1. So all of that is going to be our solution, because x can be less than negative 2, or x can be less than or equal to negative 1. So this is, quote unquote, the bigger set, so that is going to be our solution set there. So anything that's shaded, no matter if it's yellow or red, gets included. So we're joining these two sets together to give us the solution set from negative infinity to negative 1. Let's try another one. So x is greater than 0, or x is less than 2. Either or. So we're going to join these sets. X is greater than 0. So at 0, I'm going to go ahead and put an open dot because it's strictly greater than. And then we're going to shade to the right for that set. So that is x is greater than 0. X is less than 2. I'll go ahead and plot 2 right here. Again, put an open dot. And less than 2 is going to be everything to the left of 2. So notice that there is not a spot on here that's not shaded, right? And actually, we should have shaded that to yellow, right? For the x is greater than 0, it includes 2 as well. So the point is that there is not a spot on this number line that's not shaded. So our solution set is going to be everything, negative infinity all the way to positive infinity. So that is the solution to x is bigger than 0 or x is less than 2. Any number in this interval will satisfy one of these inequalities. Alright, so we want to graph the compound inequality, and we're going to go ahead and write our solution in interval notation. Okay, so we're going from negative infinity to positive infinity. I'll go ahead and put my points on here first. So we have negative 5, negative 1. I have an open dot at negative 1. I have a closed dot at negative 5, right? Now I'll do my shading. So for x is less than 1, I'll shade everything to the left of 1. For x is greater than or equal to 5, I'll shade everything, including negative 5, to the right of negative 5, including this open spot right there. And so this is an and, right? This is not an or. So all we want to include is the intersection of yellow and red. Right? And notice this open circle doesn't have yellow in it, so we're not including it when we write our solution. So our solution here is going to be from negative 5, including negative 5, all the way to negative 1, not including negative 1. Okay. So remember, and means we're looking for the intersection, we're looking for where they overlap, and or means we're including everything that has a shading, no matter what the color is. Okay, let's do this one. X is less than 10, or, okay, so keyword is or, x is less than or equal to 4. So got my number line here. I'm going to plot 4 with a closed dot. I'm going to plot 10 with an open dot. And in yellow, x is less than 10 is going to be everything to the left of 10, including that guy. And in red, everything that is less than or equal to 4, so including 4, so everything less than or equal to 4. And remember that or means that we include anything that's shaded, not just the overlapped region. So our set, we start at 10, not including, or no, I'm sorry, we start at negative infinity, right? Because we want to go from lowest to highest. And we stop at 10. And we're not including 10, so we'll put a parentheses there, because that 10 doesn't have any shading, it just has an open dot there. That's our solution. Alright, now we have an and, so we're looking at the overlap. So I'll plot my points first at 2 with a closed dot. and then at 8 with an open dot. So for x is bigger than or equal to 2, I'm going to shade to the right, including 2. And then for x is less than 8, I'm going to shade everything to the left of 8. Okay, now for and, I want to look at the overlap colors. So I'm looking in this region right here. And notice that this little dot right here only has yellow, so it doesn't have red, so we're not including 8. But the 2 does have red and yellow, so we are going to include the 2 in our set. So we're going from 2 to 8, not including 8, and that is our solution set. Alright, so that this set satisfies both of these simultaneously. X is bigger than or equal to 2, and at the same time, x is less than 8. Okay, let's look at this one. So this is or, so we're not looking at the overlap, we're just concerned with what's shaded. So we have -7, we'll do a closed dot there. Then we have 2, we'll do an open dot. So for -7, that's going to be everything including -7 to the right of it, greater than or equal to -7. And then for 2, that's going to be everything to the left of 2, not including 2. So notice that every single thing gets hit by a shading, regardless of color. So that means that everything is in our solution set. Negative infinity to positive infinity. You pick a number, any number, and it's either going to be greater than -7 or less than 2. Okay, and let's do one final, actually let's do 2 more. Let's see, yeah, let's do 2 more. Alright, so this time we have and, so we're looking for the overlap. So let's go ahead and draw our number line out. So we have, first of all, we have 1 and -6, so I'll plot those there. Now in yellow, x is less than or equal to -1. I'm going to do a closed dot, and I'm going to shade yellow on 1 and to the left of 1. So we are looking for the overlap here. For -6, I'm going to shade on -6 a closed dot, and then everything to the left of -6. And now we look at the overlap, since this is an and statement. So the overlap, we're going from negative infinity all the way up to -6, including -6, because both yellow and red shade -6. Okay, so that's our solution in interval notation. Alright, so let's go ahead and, oh, we have 2 more. They just keep popping up here. So we have another and statement. So we're looking for the overlap between these 2 sets. So I'll draw this on my number line. I have -1 with an open, 3 with a closed, and for x is bigger than or equal to 3, I'm going to shade on 3 and to the right of 3. For x is less than -1, I'm going to shade just to the left of -1. And they don't overlap at all, so this is no solution, because we're dealing with and here. If it was or, we would include both of the sets, but it's and, so we're looking for the overlap. There's no overlap, no solution. Let's do this last one here. So we have an or statement. So x is greater than -9 and x is less than 4. I'm going to just erase some of this so I have more room. So here's -9, here's 4. Greater than, I'm going to do an open circle. Less than, I'm going to do an open circle. X is bigger than -9. I'm going to shade everything to the right of -9. X is less than 4. I'm going to shade everything to the left of 4. And because this is an or statement, anything that gets hit with a shade, no matter the color, is going to be in the set. And that's everything. The whole number line is shaded in some color. So our solution here is going to be from negative infinity to positive infinity.